Future directions. Now, there's not too much we can say here because all the things we would have given you in version 11, which should have been really about in about 8 months' time, we've already given you. Because of the delays and getting some things working, we've put in snippets. We've put in all these darn modifiers. We've put in heaps of things we're holding up our sleeve. So we will show you a couple of things we're working on. Some we won't show you because we think they're going in the right direction, but we don't want to get your hopes up. So Hans is going to show you something he's been thinking about. And did you get your other report working?
Yep. Hello. We just go back to the report. I just forgot one tiny little thing is, I forgot to pick the new one, the new format I created here. So click on sample and just try something. Something like that. In the report. You can see what happened now. Now I change my logo. All right. So everybody wakes up? Otherwise I will start the music. All right. On a Monday afternoon I was working. Checking a social network and relaxing. And then something pops up. This. So I'm working very hard and then my mate is just having a good time. What life it is. Okay, so keep me thinking about social network is being more and more important. And then to understand social network is something like, say, I'm here, I'm connecting to my friend, Blake, and then connect to Richard, for example, and then connect to my mate, Lane, and of course, Lane connecting to beer. And then Lee and Alan, my bosses. Should I connect to them? Probably not. So it's some kind of a network problem and things like that. Because you know what? You don't want every time you do a status update, it says something like this. And your boss will see it. Or something like this. And then I'm going to introduce you to the new stuff we're doing. It's called 12D Social Network. Let's start to see what it is, shall we? Go there and go to V11 is a tiny bit over here. To save you a little bit of time, I'm just close this view here. Windows 8 is a bitch with the mouse. Yeah, anyway. Anyway, I just pre-create some sort of very, very simple intersection and stuff like that. And just go and create a new one. So you guys know that is not some sort of magic or something we plan ahead or something like that. But just go and create a same as this and create. Just very, very quickly just go through and put in my favorite computator. It's called fixed compound. Quickly set. Let's go to a string. Should be good. Radius, make it 20. And then I go and pick my string. It's very hard on a tiny little screen. And give it an offset of 10 meters, something silly. And go second string. And just want to go out this way. And then offset is 10 again. and set it. Okay, so here's my string. And now I'll just go and lay down some pit and pipes. So, you know, like I tried to create some sort of, actually I say social network, it means social network for the strings, not for you. So I tried to go and put down some pits and pipes and then see how they go together. Just go to design, drainage sewer, or just go to network editor. This Big Daddy is too big. It can't fit on the screen. So how about just go and put it somewhere there. I think I picked the wrong button anyway. Just go to my drainage network. It's one. And then now it's my new editor here. Just zoom in a bit here. Just go and put some pit. One there, one over there. One is here, one is here, and one is there. And now I'm just put some pipes linking this one. That, and from there to there, and from there to there, and from that node to this one outside here. Okay. Finish that. And I go to my string cat, go to dimension, put a leader in here. So what I mean by fixed pit is this thing is not going to move, it stays there because I pick it outside. It's not related to any of the string. It's very hard to use this Windows 8 here. So now let's say I want to go and edit one of the main center line. Or how about just edit this one as well. So now I just want to move this string and see what happens. Just do that. I think this is cool. And then I can go to the other string and do something like this. Look at that, the fixed pit is sitting there and the other pit is keep moving with the string with the curve return. And they are exactly 1 meter after the curve. That's what my drop told me, that is what they want to do all the time. So that's it. This is the 12B social network that we're talking about. Yeah. Thank you.
Okay, so we're now going to turn over to Alan and myself to do another demonstration. So even though we have been working on version 10, we are doing some things for the future. So what Al's just going to do is show some of the work we've been doing with point clouds and some things like that. So we showed what we did with the old grid tins and grid strings. They're in version 10. And we'll just look at some of the extra things that Al's been playing around with in his spare time, like evenings on aeroplanes, watching the tennis. Al's a very avid tennis player and goes to, tries to get to a lot of the Opens so he can take his portable computer with him, and when his favourite player is no longer playing, he can sit there and program. So whenever Federer gets knocked out, I say, ripper. That means another option's going to be finished. So Federer going all the way through at Wimbledon was a quite sad event for me. And I think it was last time when he was in the UK for the Open, I think Federer got knocked out there, previous Wimbledon, which is where Alan went up to Duxton. And up at Duxton is that's where the Blackbird is, the full-size Blackbird. That's the one place outside the US, which I think is where Alan, who's been a bit of a freak on those sorts of things for many years, started following up the Brian Schul to do his talk. So lucky, Federer being knocked out meant we got to hear Brian as well.
Well, hey, you're really lucky that Federer beat Andy Roddick in the 2009 final 16-14, because after that I was so happy and so motivated. I went and completely rewrote Super Tins from scratch and got it all working. So that was You got to thank Roger for me finishing super tins. That's the truth. Okay, LAS files. Yes, we do.
1 second, before we go on, we're onto our machine. We didn't say the other day that this was the 64-bit version, but again, this is a machine, it's a straight Dell machine. It's got 24 gigabytes of memory, which everyone goes, ooh, that's a lot. But that's what you have to get these days just to run Windows 64-bit version. If you don't get any less, you don't get much performance gains. But memory is as cheap as anything. What was that machine? $2,500, Al?
$2,500.
2,500. So it's really a base level of what you buy these days. Now we'll continue on.
Thank you. Okay, we're going to go into a little sample job that was given to me because the colours weren't drawing in V10 by a certain New Zealander. I'm sure he was colourblind, but there you go. So we're just going to start zooming in, yes, the infamous red square. And then we can go back out and it's now actually loaded this data. So this is a little LAS job, and if we go do some info on view 2, it's got about 5.5 million points. So, you know, that's not too bad a performance. You'll actually note up the top here it says Plan OpenGL View. Point clouds will have this new view type because to actually get any performance we're having to completely bypass Microsoft graphics. The Microsoft existing graphics, which they've had for ever since Windows 3.1, called GDI. It was really good up until XP, and XP was great. And then Windows Vista, they went, we can do something better, and so they completely screwed it. Totally. I mean, it was, in the old days, GDI used to be on the graphics card. But then Microsoft said, no, you don't do that anymore, and they completely rewrote GDI as software which sat on top of DirectX, and it went 10 to 100 times slower. So that's this cute little job, and yeah, that's quite cool. We're now going to move up the food chain a bit. We're going to go to a slightly bigger job, which was another job supplied to me by a customer. And we're not going to save that. And I'll just sit there thinking for a second. I hope it's actually going to function. Okay, there you go. Is that all fitting on the screen okay? No. Okay, so tile horizontal.
Now, these are LAS files, so they're point cloud data. One thing about point cloud, people have to realise, they're what we call zero-dimension data. It's dumb as it comes. You've got a point and maybe some attributes there. But there's no linkage. It doesn't tell you how the data fits together. Although that looks fantastic, it's all done by your eyeballs. The data is as dumb as it comes. So strings and things are up to the next one level and 3D higher levels. So how many points in that one, Al?
It's not too many. If we go on to that data, it's 910,474. The 4 is very important.
I've asked Alan to put commas between those things.
That is not an
can
Australian
never figure it out.
standard.
No commas.
Okay, now, you know, that colour all looks reasonably well, but for some reason Rob Graham was sitting down with me. He said, you know, why is all that, there seems to be points missing, and so he said, just go and change the view colour. So we went and did that, and we decided to change the view from black to white. And then we noticed down the bottom was all these black pixels, so where we thought we're only drawing, there was a lot more points being drawn than what you thought there was. And then that brought up a big dilemma, was, well, what do you do when the point cloud has the full spectrum of every single colour, and it can be very hard to get a grasp on what's going on. And there was a certain New Zealander who's been doing a few point clouds for some disaster recovery work. And he was saying, you know, I'm writing this macro to go and you know, recolor all the points on the fly and blah, blah, blah. So sorry, Sam, I've just completely negated your macro. But so we're going to go to view 4 here, and we're going to apply what's called a texture height map. Now, for those guys that went to Rob's 2Flow, where he was demonstrating using what's termed a 1D texture to colour by, say, water depth or by tin RL or height. RL's not a Australian standard. Yeah, we can go do this. So instead of drawing the pixel colours that's in the LAS file, we're now colour coding this point cloud by height range. So we can see down at the bottom that the green that's probably down around 17 metres, and the top of the data is about 45. So that's a really, really cool tool to, again, visualise data in yet another form. So yeah, that's 500 million points. So, well, where do we go from here? Well,
How many points? 500 million.
sorry, 500 million, yes. What did I say?
500 billion. 450.
500 billion.
Yeah,
Yeah.
500 billion.
500 million. So where do we go from here? Well, it's a bit like Brian Schul's Cessna flying over California, where, you know, I'm doing 90 knots and the next guy's doing 120, the next guy's doing 600, and he trumps them all and says, well, I'm doing 1900 miles an hour. So someone said, I've got some data for you, remain nameless, and he said, here's some data. For the observant, yes, this is basically down the Gold Coast, Stradbroke Island, Moreton Island, Bribie, all the way up to way past Noosa, out past Toowoomba and Esk, and etc., etc. Now, I'm not going to tell you how many points there are at the moment, but I soon found out it was very important to be able to toggle on and off point clouds. So we added a new toggle here called clouds. So if we turned it off, you would just go and draw the infamous red rectangle, which you're all going to learn to love. Trust me. I know what's best for you. Anyhow, I'm going to toggle the clouds off. So now it's going to sit there for a bit, and it's going to draw. So now you're starting to see some detail, and we're going to start, say, wheelie mousing into one of my favourite places in Brisbane. It's the region on the airport, because I seem to be sitting at that airport so often. And we're just going in and in, then we might decide, okay, let's start panning around a bit and head on down the Brisbane River and down past Hamilton and down towards the Story Bridge, and there you can, if you go in far enough, you can actually see some points. It looks a little bit like a Story Bridge.
You can do this all day long.
We can do this all day long, and you can have fun just looking at all this data. And we might go, well, look, we're going to go, let's go put it all in a perspective view and just do a fit. And it'll think for a little bit, and you're going, geez, this software's not very good, it's a bit slow. And we're going to put an orbit, now we're going to start zooming into, am I saying, oops, let's pick a location first and start zooming in. And it's going to take a little bit, I apologise, it's not that good, well-written software. I should add that LAS files, by the way, there's 5 different versions of it. There's 1.0, 1.1, 1.2, 1.3, 1.4. Yes, I'm stalling while it's drawing. You got me. And 1.0 and 1.1 actually has 2-point formats. 1.2 and 1.3 has 4-point formats. And 1.4 has 11-point formats. So that means there's approximately 20 different odd formats, or 25 different formats, that we have to support to be able to draw LAS. Well, did someone ask how many points there are in this? Come on, someone ask me, please, please, please. How many points are there?
Zoom in a bit further. I want to see you go slow.
Come on, people. Yeah, it's a guessing competition. Whoever gets as close gets.
No.
Sorry, how many? 2 million. How many? 200 billion. Jesus Christ, we're not that good. Lower your expectations. Come on, keep going. Come on. This is like Price is Right. Anyone? 20 million? Oh, billion. Hang on, you work for us. You can't guess. Ignore that bid. That's insider trading. 15 billion. Okay, you're starting to get close, and I'm going to put you out of misery, because if I keep playing around the demo, I might crash, and then I'll just look stupid, so instead of being a smart ass at the moment. Okay, so here's all the data, and we're going to sort by the number of user points. We'll start down the bottom. There's this little one here, which is river called It's got 15 million points. The next one's got 104 million, the next one 183 million, next 33.6 million, 33.7 million. Okay, we're up into 1.2 billion, blah, blah, blah. Sunshine Coast has got 7.74 billion. So, does everyone know about view info table in V10? It's really great for debugging when there's a bit of data that's got a crap X, Y or Z because you're going fit and it's just nowhere. You can actually see every model and what extents there are and points, etc. Okay, view info, drum roll, on view 2. And no, there's no commas, so I'm going to space it out for you. So I think that is 30,661,952 and 548 points. Okay, it's not all good news. Basically, when I got given this data on a USB 2 drive and transferred it onto this computer, which actually we had to put a spare 2 terabyte drive in, because this information occupies just under 800 terabytes of disk space. Windows took just under 6 hours to copy all those files from one drive to another. So you've got to keep your expectations a bit that, you know, hang on, Windows is just doing a file copy. It's doing nothing intelligent. It's not looking at the content of the data. So we're obviously doing something to get through that much data. And so we have to do a process called indexing, which you probably heard that term being used in Synergy, where, you know, Richard talks about, okay, when extra files are being added into Synergy, Synergy will take a certain amount of time to go and index the new information for the keyword searches. For us to, once the data is sitting on that disk drive, to index it, took about 4 or 5 hours to index the 30 odd billion points. But once you've done that, you can then start working around the data in some sort of fashion. Now, I'm absolutely not going to say you cannot triangulate that many points in 12D currently. You just can't do it. But that's where grid tins come in so important, because, you know, we can go, look, I want to go and create a grid, and no, I don't want to do that, you moron. We want to go to file input, and we want to go to point clouds under LAS, and we're going to say, well, look, I'm going to go navigate now to where all the data's sitting, and let's choose Brisbane, and that'll do, and we've got the 1,664 files. I should add, this data is actually 14,000 odd files. And so most times everyone's going to head straight to this grid option and go, you know what, I'm just going to go do a grid string or grid tin. I'm going to do it every, 25 meters as a cell, whatever, and then go do your processing. This origin is actually just a notional origin, say that if the grid was to go through, the grid has to go through that point or a virtual point on the grid, so usually it's 0, 0. And then you would just read all that data in and filter it down to something that's actually manageable. So, because I don't think your IT people at any organisation is really going to be too happy about you trying to drag all that data across a gigabit network to do anything with, because you'll saturate the network and they'll just disown you. So yes, memory is important. On my machine at work, which has 64 gig of RAM and SAS disk drives instead of the just standard blue drives, was it? Which is basically 5400 RPM drives, which aren't the eco-friendly ones, but it's not as bad as the faster black drives. I can do most things with this job upwards of twice as fast with better disk drives. So if you want to do this sort of processing on the cheap and get really cheap hardware, no memory, things like that, that's the first question I'm going to ask you is, when you ring and you're going, it's going too slow, what hardware have you got? And if you say, oh yeah, it's a little with 8 gig of RAM and things like that, I'll give you a hint what the answer is now.
Right, so that's a bit of an idea. We're just out of time. To give you, we are working on some things. If that data Alan's got there, if you went to say those string, to create a string, you can click between those points, join the dots, all that sort of thing quite happily. So all the normal 12D operations work for it, for using them as data points.